Alright, that ended the multiple choice part. Now we've got free responses. So I'm given these two pieces of information, which I must use to solve these problems. So here we go. How can I make 18 in terms of 2 and 3? Well, it's 9 times 2, isn't it? And what's 9? 3 squared. So I can expand this now. So I add because I'm multiplying, and because I have a power, I can drop that in front. All right, I know log base 5 of 2 is 0.4307. And I know the log base 3, whoops, the log base 5 of 3, forgot to write that, is 0.6826. So when I add all that together, I get 1.7959. All right. So this one, if I'm dividing, that means I'm subtracting the logs. Now I know what you're thinking. Wait a minute, log base 5 of 5, I have a log of base 5 of 2 and a log base 5 of 3. I don't have log base 5 of 5. What am I supposed to do? Think about it. What's the log base 5 of 5? What power of 5 will get you 5? It's 1. Log base 3 of 3 is 1. Log base 7 of 7 is 1. This is just 1. And we subtract the log base 5 of 2, which is 4307. Do a little subtraction, and we get 0.5693. Got a lot of log base 5s. A lot of log base 5s. So let's start doing our properties. If that's out in front, I can make that into a exponent. Same with this. This 1/2 can become an exponent. And maybe we can calculate those. Nothing to do over here yet. We got to get all this as 1 log. What's 64 to the 1/3 power? Or what's the cube root of 64? It's 4. What's 49 to the 1/2 power? The square root of 49. It's 7. So if I add these logs, it means I can multiply these values. And 7 times 4 is 28. Notice I have log base n of 5, log base 5 of n, sorry, and log base 5 of 28. So n is 28. All right, here we go. We're subtracting. We have the same base, but subtracting means we divide. This is a single log over here, so we're good. Now we do our little conversion. Remember, it's 6. Our base is 6. Six to the first power. All right, then we just do a little cross multiplying. Multiply both sides by 3a. So we have 5 minus 2a equals 18a. I'm going to pop that over here. Add 2a to both sides. Divide by 20. That's 1/4. We have an unknown exponent, so it's time to log. Doesn't matter if you use ln or log, as long as you use a log. Okay. So if I make take the log of both sides, that means that n plus 3 comes down. I have log of 7, log of 80, isolate the n, so get rid of the log 7. So I have n plus 3. And I put this in the calculator, and log 80 divided by log 7 is 2.2519. Subtract 3 from both sides, I get n to be negative 0.7481. All right, we're getting there, almost done. This one looks a little interesting because you might think, oh, I can make this the same base. I don't have to do this log stuff. Well, you can't. 3 and 6 don't have the same base. 6 to what power gives you 3? Or 3 to what power gives you 6? No, it's close, but it's not quite there. So we're going to do logs. And this time, maybe for fun, we'll do a natural log. It doesn't matter as long as you do the same thing to both sides, because you will get the same answer every time. All right, n drops in front. N minus 2 drops in front. Same as before. We're going to have to distribute this through. So n times natural log of 6 minus 2 times natural log of 6. So I have n here and here, so I got to pull those together. I don't know why I did it that way. N natural log of 3 minus n natural log of 6 equals negative 2 natural log of 6. They both have n's, so we can factor it out. So I'm going to divide both sides by natural log of 3 minus natural log of 6. Throw that all in the calculator. And that's what we end up getting. All right. Good job, guys. All right, let's put these together again. I have $500 I put in my savings account. It's paying 4% interest after 5 years. So guess what? I'm just going to put that on the calculator, and it's going to give me an answer of $610.70. Now, only $110 after 5 years. Doesn't feel like a lot, which means the more money you put in, the more money you get out. Now, but think it's exponential. So even though 5 years, it's only going to be $110, another 10 years or another 5 years is going to be more than just $100 more. It's going to continually increase. All right, solve. We have a natural log. What's the old inverse of that natural log there? E. That's one way to do it, because these cancel out. And subtract 4 from both sides. So x is about 50.5982. Now, if you think about it, you don't like doing it this way. Remember what natural log means. It means a log base e. So if I take this e and I move it over, it means that x plus 4 equals e to the 4th, which is the same thing you get here. So, however you like to think about it, that's fine. I like to do it this way, but it really means the same as this. So, either way is fine. E, the negative 3x, is less than or equal to 18. Well, I'm going to give myself a little bit more room here, because what are we going to do? How are we going to do an e? A natural log. That's a terrible natural log. Let me try that again. I know my natural logs sometimes get really sloppy. Alright, kind of cancel each other out. I say kind of cancel each other out because what I mean is the negative 3x drops in front and the natural log of e equals 1. but that's just a little shortcut to do it that way. And the natural log of 18 divide both sides by -3. Now it's just like a standard inequality. If you divide or multiply by a negative number, you got to flip the sign. And natural log of 18 divided by -3 is -0.9635. All right, 2 more problems. All right, another radioactive decay. See, 5 years. Starts at 100 grams. It goes down to 75. Find K. Okay. So the formula that's given to you on the worksheet, and I didn't give it to you here, but I said I will, is this. Same formula as the one for compound interest. So Y is where we're at now. Now we're at 75. A is what we started with. We started with 100. K, we don't know, but we want to know what happens in 5 years. So there's our one unknown, K. Do a little division. 75 divided by 100 is 0.75. E to the 5K. And how do you undo an E when you're looking for an exponent? Natural log. Oh, that was a bad 5. All right. That's gone. 5K drops in front. So what we're going to do is the natural log of 0.75 is -0.2877. I'm going to divide by 5. And K is going to equal -0.0575. All right, find the constant K, which we did, then write the equation. So the equation will be Y equals 100 E. The K is 0.057. Whoops. Try that again. 0.575 T. So we found the value that makes it go down, and T is the time. So if I want to know what happens in 20 years, I plug 20 in for T. All right, last one. Another savings account. We're earning interest. Yay. Oh, I kind of missed something here. Well, what's our Y value equal? Remember, our Y is what it equals currently, or what we want it to equal. We want it to equal 900. It starts at 300. And we know our rate is 5/8%, which is 0.058. Well, we got everything we need, so we're looking for T. So 900, 300, 1 plus 0.058 raised to the T power. All right, so we do a little calculations. Divide both sides by 300. We wanted to triple it, didn't we? So it's 3. All right, then we got 1.058 T. How do you want to do it? I'm going to do a log, a common log of base 10, a natural log. It's really up to you. What did I do? I did a natural log. So, and it doesn't matter. You know, let's just do a log this time, because we're allowed to. The only time I make sure I use natural log is when there's an E involved. Otherwise, it really doesn't matter. Because what does this T now get to do? It gets to drop in front. And once that drops in front, I'm going to divide both sides by the log of 1.058. So if I take log of 3 and divide it by the log of 1.058, I get that. So it takes about 19.5 years. That's a long time to triple. But again, it was only $300. And I say only. It seems like a decent amount of money, but really, it's not for life. So the more money you can put away and save, the better, because you can make more. That's your lesson for today. All right. On our chat tomorrow, on May 21st, and that's when I will post the assessment. So good luck, and if I don't see you guys tomorrow, have a great Memorial Day weekend.